How are you, my friends? This video is presenting questions 43 to 56, Group D, from the 70 old exams review questions for the complete algebra course from lecture 1 to 39. Let's go. Question number 43. Solve the equation for x. We have x and m in the equation. If we need to solve for x, that means we can rearrange the equation as x squared plus square root of 5 m plus 3x plus m squared plus 10m plus 5. So in this case, this is a quadratic equation where a is equal to 1, b is equal to this, and c is equal m squared plus 10m plus 5. So we can find the discriminant. Capital D is b squared minus 4ac. Then you can check the numbers, please. And then we can find x by the quadratic formula, minus b plus or minus square root of capital D divided by 2a. And we have here square root of m minus 5 squared. It will be the absolute value of m minus 5. That's the x. Now here we need the sum of the solutions of this equation. Cube root of x plus 6 root of x is equal to 2. This is an easy equation. This is a quadratic in form. We can change all the powers here to be rational powers. And then let x, capital N is equal x to the power 1 over 6. If you square both sides here, you get n squared for x to the power 1 over 3 plus n minus 2, factor it, n plus 2, n minus 1. And then n will be minus 2 or n will be 1. So if n is minus 2, that means x to the power 1 over 6 is equal to minus 2, which is rejected because the index is even. 6th root of x cannot be minus 2. Now you check the second one, n is equal to 1 over x to the power 1 over 6 is equal to 1, so x will be 1, which is correct, so the sum will be only 1. Now this question is a standard question. If the slope of the line passing through the points A and B is minus half, find the distance between the midpoint of the line segment AB and the origin. So we have A and B, and there is K inside. So we have to find K, since we know the slope of the line passing through AB is minus half. Then we find the midpoint, then we find the distance. So we have here the slope formula y2 minus y1 over x2 minus x1. So just plug in the numbers is equal minus half. Then you can find K will be 8. Then I find the midpoint of AB. So that's minus 4, 5, and this is 8 minus 1. So the midpoint x1 plus x2 over 2, y1 plus y2 over 2 will be 2, 2. Let's find the distance between the midpoint and the origin. The origin is 0, 0. So the distance will be square root of 2 minus 0 squared, 2 minus 0 squared, which will be 2 square root of 2. Solve the equation. This is a rational equation where we have a variable in the denominator. So what do we have to do? The main idea, factor the denominator, find the LCD, multiply on both sides the LCD. So the LCD will be x times x minus 3 times x plus 3. Remember here, we had this side here inside, you see, 3 over x minus 2 over this, multiply by the LCD, equals this one here, minus 12 over this, multiply by the LCD. Now, if you multiply the LCD by the first term, you will cancel the x, so you have 3 times this. Minus 2, cancel only x minus 3, you will have 2x times x plus 3. Here you cancel x plus 3, x minus 3, so you are left with minus 12x. Rearrange the whole equation, you get quadratic. X squared plus 6x minus 27 is equal to 0. Factor it. So we have two solutions, x equals 3 and x equals minus 9. We have to check each solution in the original equation. 3 is rejected because it will make the denominator 0. So minus 9 is the only solution. We have a function f and a function g, and we need the domain of f circle g. Now, to find the domain of f circle g, we have to find first f circle g. So g, all of this, we replace it in the x of the function f. So we find f circle g, it will be big square root of 4 minus square root of x minus 2. Now, to find the domain of this, we take the radicand greater than or equal to 0, rearrange this, and then square both sides. So you get x minus 2 less than or equal to 16, x less than or equal to 18. So from minus infinity to 18 is the domain of f circle g. But remember, we have to find the intersection with the domain of g, because the domain of g is where we started with. So x minus 2, this is the g, greater than or equal to 0, x will be from 2 close to infinity. Find the intersection between this, and you will get closed 2 to 18 is the final domain of f circle g. Now this one is easy. We have function f and function g, and we need the zeros of f minus g. Here we have to find the function f minus g as a new function. So we find the function f minus g, let's call it capital M, just function m. So f minus g, we just subtract, we get x squared minus 5x plus 6. To find the zeros, we let y equal 0. Y means m of x. And then we factor the equation. So the zeros are 3, 0, and 2, 0. So easy question. This one is a medium, maybe. If x equals minus 3 is the axis of parabola of this parabola, we call it axis of parabola, we call it axis of symmetry also. And this is the equation of the parabola. F of x is minus 2x squared minus 4cx minus c squared minus 29. We need to find the maximum value of f. So first we have to find the value of the c here. So we go by the vertex formula. See, h is minus b over 2a. So minus b, you see here, 4c over 2a is equal to minus c. But given the axis of parabola is minus 3, so c will be 3. So now the function we can write as minus 2x squared minus 12x minus 38. Now we need the maximum. Why there is a maximum? Because a is negative, so it's opening down. So there is a max here, the maximum value in the range. When we say find the maximum value in the range. So k will be the maximum. K is f of minus 3, the axis of symmetry, which is h. So replace minus 3 in this function after we found c. So k will be minus 20 is the maximum. Factor the polynomial function completely. This is really nice. We have f of x, x to the power 4 plus x cubed minus 3x squared minus 5x minus 2. Not easy to factor, but we need to factor completely. So we go to rational zeros theorem, p over q. So p, all the factors of the constant term here, minus 2, plus or minus 1, plus or minus 2. Q, the factors of the leading coefficient here, 1, so plus or minus 1. Divide every p by every q, you will get plus or minus 1, plus or minus 2. Now we have to try synthetic details on the next slide. So you have to try synthetic. You put the coefficients here, 1, 1, minus 3, minus 5, minus 2. Make sure there is no missing term. Then we start with 1, then minus 1, until we factor the function like this. X minus 2, this is the factoring of this. X minus 2, x plus 1 all cubed. Let me show you on the next slide how you do that. So this is the function. I put 1, 1. You see 1, 1, minus 3, minus 5, minus 2. So if I divide, I can divide by 1. 1 is not a 0, so I can divide by -1. See, 1 comes down, -1, that's 0. Multiply 0 and -1, add. This is 3 minus 2, multiply with -1. So remainder 0. So that means -1 is a 0. So x plus 1 is a factor. Try it again. Every time you get a 0, you try the same number again. So 1 comes down, -1. This is -1, 1, -2. So the remainder is 0 again. So -1 is repeated. Try it again. Let's see, -1. 1 comes down, -1, -2, 2, 0. So repeated 3 times. So x plus 1 all cubed. See what's left in the quotient? X minus 2, we write it here. Now, if the quadratic equation minus square root of 5x squared is equal this is written in the form x plus m all squared is equal to n. Let's find the value of mn. See, if you look here, you find too many radicals there, no problem. We have x squared and x, so this is a quadratic equation. We have to use completing the square to put it in this form. All right. So let's rearrange the equation. Here we can multiply by -1 over square root of 5 to have x squared here, because we need the leading coefficient to be 1. So we multiply by -1 over square root of 5, -1 over square root of 5, -1 over square root of 5. We have simple equation now. X squared is equal to square root of 5x plus 5. Easy now. So bring all the x's together and then take half the coefficient of the x and square it. So it will be 5. So we add 5 on this side, 5 on this side. We have already 5 from the question. So this becomes x minus square root of 5 squared, because we have a minus in the middle, is equal to 10. So when you compare it, this is what we need, x plus m. So m will be the minus square root of 5. Be careful there. N will be 10. When you multiply them, you get minus 10 square root of 5. Graph the polynomial function. After you do that, you answer the question where the graph is above or on the x-axis. It looks like this is a polynomial function, but we have to factor it more here. So you have to factor it more to see the real zeros. The real zeros are the x-intercept, the most important points on the graph. So let's factor more and more. So we can factor this. You see here we have x minus 2. So this one, x minus 2, x plus 1. So now the function becomes x power 4 there, x minus 2 cubed, because we have squared and there is another x minus 2 there, and this one is a squared. So we can see directly the zeros are 0, 2, and -1. See, -1, 0, and 2. And now the degree here will be 9, and the leading coefficient is positive. So this is like the cube, up to the right, down to the left. So the graph will be tangent here at 0 and tangent at -1, because even multiplicities, and it will cross at 2. So where the graph is above the x or on the x at -1 only, on the x at 0, at 2, and then above 2. So it will be -1, union 0, union 2 closed to infinity. This is above or on the x-axis. Find two numbers whose sum is 26 and whose product is 105. So for sure we can start by saying let x be the first number and let y be the second number. So their sum is x plus y is equal to 26. And the product, so y will be 26 minus x, the product will be 105. So I can replace y here, 26 minus x, in this equation, in the product, and then I multiply, rearrange it, I get x squared minus 26x plus 105. just factoring x minus 21, x minus 5 is equal to 0. So x will be 21 or x will be 5. So these are the two integers. Complex numbers here, I to the power 28 plus square root of minus 1 times square root of minus 4. Here we have to subtract. If this is equal x plus y I, we need to find 6x over y. So we have to write this in standard. Then we take x and y, we find this value. Remember here, a big mistake you can do, please do not do. Do not multiply directly here, make it 4, square root of 4. What can you do? You have to replace square root of minus 1 by I. Square root of minus 4 is 2i. You see? So I times 2i, 2i squared, which is I squared is minus 1 times 2 minus 2. I to the power 0 is 1. Why I to the power 0? Divide by 4, 28, and take the remainder. So all the numerator is minus 1. Here we subtract, you see? Just subtract, you get 5 plus 3i. Multiply by the conjugate, you know how to multiply easily. Then you get minus 5 over 34 plus 3 over 34i. So this is x, this is y. So put 6x over y will be the answer minus 10. Now let's go to inequalities. Solve the rational. This is a rational inequality where we have a number on this side or any side. You can move all the terms on one side. It's easier in this case to go to the left, greater than or equal to 0, and then you can combine. See, I take minus 2 on the other side, rearrange it, plus 2, and then find the LCD on the left side. We combine it, 25 minus x squared, and then cancel the 50 and minus 50. We have x plus 3 over 5 minus x, 5 plus x. So the zeros are 0 minus 3, 5 minus 5. We have to make a big table. You know how to do the table. Choose a point here, put all the pluses and minuses, and then choose the plus here, greater than or equal to 0. But make sure that we have to check at the end. Why? Any number will make the inequality 0 in the denominator. We have to make it open. See the 5 and minus 5, I make it open and open. Everything else should be closed. Now, if E is the solution of this absolute value inequality and F is the solution of this absolute value inequality, find E intersection F. Now, this is clear that we have to solve the first one and call the solution E, solve the second one and call the solution F. Now, first one, we use case number 2 because we have absolute value, you see, the absolute value less than 11. So 3 minus 2x between minus 11 and 11. So this is case 2 here. You can find this in lecture 26. So x will be, so the solution E now, closed interval from minus 4 to 7. Now, this one you have to rearrange. You see, take minus 6 on the other side with the 1 becomes 7, divide by 3. Now we have this one, absolute value greater. You see up here, absolute value greater is case number 3. So it will be the expression less than minus 7 over 3 or this one greater than 7 over 3. Now each one is linear. When you solve it, you get x less than minus 2 or x greater than 5. This is solution F. Now on the next slide, I will show you how to draw solution E, solution F, find the intersection. Now, solution E from minus 4 closed until 7. See, this is E. F from minus infinity until minus 2 open. And then from 5 open until infinity. It's very clear we have intersection there and we have intersection there. The intersection here closed minus 4 to minus 2 open union, this part open at 5 to 7 closed. That's E intersection F. Thank you for watching this part D. If you like the video, you can subscribe and share it with your friends. And let's meet in group E, the last part in this old exam review questions. Thank you very much and bye.